Wanted to go over a few housekeeping notes. Please make sure your cell phones are turned off or put in vibrate mode. And we will have some speaker evaluation forms. We don't have them right now, but we will at the end of the day. So if you could fill that out, we appreciate it. We also hope that you would be able to join us tonight for a reception in the ballroom. Tonight, there's going to be dinner, drinks, and gives you a good chance to network with some of your colleagues. This session is presented by Christian Heinrich, and he's going to be talking about a Google hacking project. One of the interesting projects that OWASP is involved with, and definitely should be very informative. Let me give you a quick bio of Christian. Christian has over 12 years of professional experience and formal training in diverse disciplines of security, ranging from locksmith, shot firer, bodyguard, IT engineer, and chief security officer. He has been promoted several times within the Australian government based on his performance within projects for the defense and intelligence services. By reputation, this led to several more projects within 4 major banks of Australia and other, I guess, New South Wales, and NSW, New South Wales Government Critical Infrastructure, and is regarded as a thought leader for the security within the media and telecommunications industry. He has contributed to numerous security articles in the Australian newspaper and online to ZD Australia and Computer World. Please join me in welcoming Christian.
Thanks, everyone, and good morning. Okay, just a couple of notes. I will actually be publishing this presentation later on SlideShare. I suspect after October the 20th, which is actually when I return to Australia. If you do download it, there is content within the notes section, so supplementary in terms of references and that kind of thing. And it's licensed as a dual license, so it's licensed under whatever license OWASP consider, as well as an Australian Creative Commons 2.5 license for attribution non-commercial, and no derivative works. As stated before, I have 12 years of purely end-user experience. I actually started my career within the Australian federal government, doing work for the intelligence services, as well as running a DSD certified gateway. And I also managed the security of a federal government endorsed business. And then more recently, I started working for the New South Wales state government within critical infrastructure, specifically the electricity industry. And I also presented at the New South Wales Government State Security Management Forum on PCI DSS, and essentially contributed to a large piece of advice which resulted in the New South Wales Government rejecting it. And finally, I've presented at a number of security conferences. The most prominent one I'm known for is RuxCon, which is the Security Community Conference in Australia. So I presented there in 2005 and 2006 on defeating intrusion detection, and my second presentation was on the Common Vulnerability Scoring System. In relation to my OWASP work, I recently, which were in version 2, spidering and Googling. I'm today going to be talking about one of these proof of concepts, which is the download index cache program. There's another one called TCP input text, which is specifically related to mining TCP ports from Google search results. And there's also, I'll be releasing at other conferences, which I'll cover later on, a workaround in relation to the Google Translate function. And I presented at the recent OWASP Australian conference. I also have a profile on LinkedIn if you want to look me up and see who I know and all that kind of thing. Okay, so for the September 2008 update, what I'll cover in detail is the updates to the testing guide version 3, the download index cache proof of concept, and I'll finally do some project management in terms of I need reviewers for this project, so I'll cover the requirements for that later on, as well as presenting the project roadmap. This project itself was accepted by OWASP in June of this year, so we're kind of, I guess, using this forum to sort of update some of the project management aspects of it. Any questions so far, or? Yep. Oh, okay, sorry. Okay, so I'll just cover the spiders, robots, crawlers section. So essentially what they are, basically they just automatically traverse hyperlinks of a web page, and then they recursively retrieve content which is referenced by that within that web page. So essentially it's not recursion as it is sort of algorithmically, it's basically it just follows hyperlinks and then just downloads the content. There are a couple of differentiators within them. Some of them are able to apply heuristics, so they can, for instance, not download MP3 files or JPEGs or that kind of thing. And the other thing is too is that some of them will give you the ability to submit HTTP requests at random intervals. So essentially that means we don't overload the web server by banking it up with a number of requests. Okay, so their behaviour is actually governed by what's known as the robots exclusion protocol. Now there's two forms of this. This is the more newer form, which is the HTML meta tags. And essentially what we do is we embed tags within our HTML code. The example I've used here is the one for Googlebot, which I'll pretty much be covering in this presentation, which is the crawler of Google. And essentially what we can specify within the web page is for it to not follow any further hyperlinks on this page or to not cache the content, that kind of thing. Now, it's not universally supported by all robots that have been created, so it's not really recommended as a primary control. You would probably want to look at it as, I guess, specifying for your web developers to embed it within their content as not required, but it's fairly hard to manage and I guess maintain from there. So the more traditional one that we have is the robots exclusion protocol, is the robots.txt file, and it's located in the web root directory of our web server. In this case I've used the URL for Google because Owasp doesn't have one. It does support regular expressions, but again, they're only supported by a minor number of spiders, robots, and crawlers. So again, using regular expressions isn't actually recommended, but some, such as Googlebot, do actually support it. But the support of that too isn't as expressive as what you can get in sort of Perl or the regex library. Okay, so to essentially, the first phase of the Owasp testing guide version 3 is to basically retrieve the robots.txt file. Now here what we've used is just wget to pull the file down. It's fairly simple. I have a video of this, but I won't display it because it's pretty much that output. And all it essentially does is we just pull it down as the text file as it is. We can also pull it through with a web browser by going straight to the URL. From there, as I specified before. But there's a lot of ways of doing it. So essentially what it looks like when we pull it down is like this. Now this is the actual one from Google. I've put ellipses down the bottom there because it does go for a number of pages, but I'm just going to use this one as the example of inspecting a robots.txt file. So we have a number of statements within here. So we have the user agent statement at the top, and then we have a number of allow and disallow statements. So I'll cover those in detail now. The user agent directive essentially specifies the behaviour of an individual bot, an individual robot. So what we can have here is we can use an asterisk to apply to all spiders, robots or crawlers. Or what we can do is specify a particular user agent. So in this case, the specification for the Googlebot is obviously Googlebot. So we can then say for your particular robot, this is how I expect it to behave when it comes to retrieve content from my web server. And we also have the next directive, which is probably the most important one, is the disallow directive. Now what this essentially does is say from any path that's on my web server from here on, do not put your robot down there because it's either quite a significant amount of content or the content is dynamically generated, so it will actually impact the capacity that my web server can serve web pages at. Now, in specific to Google's thing, they've obviously put the news, search, groups and images, which obviously for them is updated quite continuously when new content is indexed. But the important thing with the Disallow directive is to not use it for actual access control, because it can be intentionally ignored by robots. So there are some robots out there that will actually look for the Disallow directive and then essentially apply heuristics to the content and then sort of retrieve the content from there. The other thing too, especially in relation to Google, is you can't use it for, don't rely on it for digital rights management in terms of how your content is actually published by third parties. If you don't want your content published, use the access control mechanisms within the actual web server itself. So essentially once the content's released, you've got to have a method of pulling it back. So there is Google do actually provide a tool to test how the actual robots.txt file is and how it's actually inspected by Googlebot, and that's done through the Webmaster Tools, and that itself simply is done through the dashboard. You just click on the URL that you've added to your Webmaster Tools, click on the tools from there, and then you just click on the Analyze Robots.txt file. So it provides you with a spiffy HTML or web interface to be able to check content from there. Any questions? Okay, so I'll now cover the Search Engine Discovery Reconnaissance section of 4.2.2 of the OWASP Testing Guide version 2. Okay, the current methodology for Google hacking at the moment is to actually run single search queries. So what we have here is a number of queries that will pull up content. So for instance, to pull up Microsoft Remote Desktop Web Connection, we use the Untitled search operator from Google, which essentially will find content within the HTML title, and the content we're looking for there is the Remote Desktop Web Connection, and within the actual URL, which is specified by the Google in URL search operator, is TSWeb. To find virtual network computer Java applets, we look for VNC desktop, and in the URL we're looking specifically for TCP port 58,000. And for Outlook Web Access, we again use the in URL, which will find locate contents with specifically that URL. So in this case, we're either looking for exchange/login.asp, or we can look for the in title, because there's two versions of Outlook Web Access, so we can look for, obviously, within the title of the HTML document, Microsoft Outlook Web Access Login. And finally, we can locate PDF files or a number of other different file extensions. So, for instance, to locate PDF, we use the file type operator. Now, the problem with using this methodology is Google have essentially cottoned on to this, and now basically returning we're sorry for specific searches that you try and run. Now, the reason that they do that is to basically stop people or automated worms and like Sasa and those from searching Google to locate vulnerabilities. Now, this goes back to the Rise of the Robots paper in FRAC, which essentially meant that you would retrieve content from a web server, store it somewhere, and then when vulnerabilities became known, you would then go back to that content and mine it and then be able to launch your exploit from there. Now, every time we get one of these we're sorry return pages, it actually impacts what's known as the Google SOAP Search API key, okay, which is, I'll cover later on, which is part of the download index cache project. And so that essentially means it reduces the amount of effective searches we can drive with our API key. If you do actually want to read a paper on this, Google have actually published one by Niles called Search Worms. I believe it was presented at Usenext, but I'm not quite sure. But you can locate it on Google, obviously, by searching in those terms. Now, there is actually ways around this we're sorry screen, and essentially what it means is we launch different search queries, but they return overlapping results. So you were able at one stage to actually polymorphic sort of your search query. So if you changed for like a PHP and you change it to lowercase p, uppercase h, lowercase p, Google would return the results. They're now actually applying some sort of polymorphism to it to basically do sort of simple regular expressions, but not to the point where it's actually impacting what Google would do for search results, because obviously they want to return the results as soon as possible, and it would therefore impact their business. So it is possible, if you run these results, if you run your queries by hand first, find out which ones you return are we're sorry, and then you modify the queries before you load it into your tool, then you can get round this section. Or sorry, you can get round this being returned.
Sorry, a question?
Yes?
I might have missed out on something, but what's the goal of this? Are we trying to find vulnerabilities by Googling stuff, or are we just...
No, I'll actually cover the methodology in terms, but the previous goal...
Why are we doing Google hacking?
From an OWASP standpoint?
From every standpoint.
Well, okay, that's an interesting question, because I'm actually a reverse engineer by trade. I don't generally do this stuff. In terms of this coming into OWASP, I actually did a presentation at an ACM Computer Security Day back in November of 2007. I then presented this in Australia, and that's how the project sort of started from there. To actually do it is to actually locate vulnerabilities that you don't find with traditional port scanning or that kind of thing. So you can use Google as kind of like an anonymous proxy in terms of actually locating content without just revealing your client IP. And the way you actually do that is to look at the cache page and then apply the strip1 parameter to the search from there. But essentially, if you're looking for vulnerabilities on a client site, you can use this as a way of actually finding it without, I guess, physically touching their infrastructure. The other reason for looking at Google is if you reverse the search results and you start from, say, the last result returned and then recursively go back from there, you'll actually find content that's probably not meant to be public or is less public and less popular. So that's where you'll also find a lot of your information leakage and that kind of thing. There is actually, you probably want to look at the one I did at Australia. That actually goes through the background of it. I would have done that today, but obviously for time constraints, couldn't have. But there's approximately sort of 5 operators you need to know. There is, for instance, the Google hacking database, which has a lot of these queries. Some of them work, some of them don't, so you've just got to kind of update them from there. But any web page that you take, for instance, you write a web application, if you specify all the Google search parameters, you can then locate it as it's sort of leaking from there. So just to take me back to where we were. So while we have that ability to do individual search queries from a corporate standpoint and from a testing standpoint and a penetration testing standpoint too, we really don't want to look at the entire internet to find vulnerabilities only. We also want to find what content is leaking and obviously record a record of that content. Now, I'll cover these 2 operators now, but site essentially restricts search results to a specific domain, and then the cached operator basically will pull what has been indexed by Google within the actual Google cache itself. Okay, so with the site operator, as I mentioned before, it returns results specific to a domain. Now, we have 2 ways of using it. One is we can use it against a subdomain or a host, so in which case we can, if we add www in front of google.com, we can restrict our results to that host only. If we do site.google, as you can see, we not only get the more popular www.google.com, but we get video.google and a number of other sites. So essentially what you want to do is when you actually run a site query, is restrict it from running just at on the web server itself. You want to run it from the top level domain. But if you need to narrow your search results down, you can actually do that by specifying the various host or subdomain in front of it. So if we had a web page or a website and we wanted to see when content was added by Google, that kind of thing, we can actually use Google Alerts to do that. Now, there's two ways of doing it. You can do it just by specifying an email address, which is on the right-hand side of this slide here. Or we can actually log on with our Google account and then manage the Google Alerts from there. So essentially what we just enter in is our search term, so it's site and whatever our domain is, then specify when we want the results. Generally I prefer to get notified as soon as it occurs, and then from there we can specify the content from there. Now what you can also do is, if you do actually have a web application that you're running on a number of different sites or for customers, that kind of thing, or you want to check that information isn't leaking, you can actually add it in there too using the various search operators and then using the individual search queries from there too. Okay, so the next operator, so once Google has come along and indexed our content, it's then stored within their cache. Now, to actually display the web page as it's indexed, we use the cache search operator. So in which case, the example here is the Owasp.org web page. We can actually include within the cache operator, if I was to write Owasp after that search query, we would get the highlight, every Owasp or every text reference to Owasp there would actually be highlighted within the cache page itself too. So it does provide us with some function of pulling it through. One thing I will add though is the graphics themselves are actually downloaded from Owasp.org. So if you wanted to be anonymous when you're doing this, you would add the strip1 parameter to the URL in the address bar there. Okay, there is another way of actually finding it, and this is a combination of using the site operator and then locating the individual pages. So for that, what we would use is we'd run the site query, as you can see up the top there, and then the individual cache buttons we could click, and which would then give us the return result of what is here. So we'd have to do that for each individual web page. Okay. Any questions? No. Okay, so I'll now cover which is, I guess, the main content or part of my talk, which is the download index cache tool, which essentially will do a site search of a particular URL or domain, and then from there it'll pull down each of the individual cache pages. So essentially what we use to achieve this is the Google Soap Search API. Now, in terms of actually programming to this API, our search query is actually limited to 10 words only. The latest estimation I have in terms of it running a search via the Google web interface is 34 words. So you can see you need to streamline your queries quite exceptionally to put them through. So if you're using queries, for instance, that have all or a lot of stop words, which are common English words, you need to trim those down or run them as multiple sort of recursive searches. The searches themselves are also limited. If within the 10 words, you can only use 2048 bytes within that. So it's possible even further to reduce the amount of words that you have available. Now, with each Google Soap Search API key, you're limited to 1,000 search queries per day, and you can only search up until the 1,000th search result. Within the API itself, it specifies the first result as 0, so that's why it's 0 to 99 there. So this provides us with up to 10,000 possible search results, using 10 different search queries. So essentially, via the limitation of 1,000 search queries per day, which are limited to 1,000 results, you times that by 10 and you therefore get your 10,000 possible results. Now, the results are also possibly can be reduced also if you only have, say, 800 of your, there's only 800 search results returned, or a number less than 1,000 by Google. So it's driven by various SOAP messages. So the one here is to make the SOAP request, we use the doGoogleSearch SOAP message. This code is actually taken from the Perl script that's actually used to drive the download index cache tool. So what we have is a number of parameters that we specify when we do when we pass the doGoogleSearch message. So we have the key parameter, which is our Google SOAP Search API key. We have our query, which is our Google search query, limited to 10 words or 2048 bytes. We have where we're going to start the query from in between the, so we don't have to start at 1, we can start at results 10, which is obviously 11 if you add the 1 to it, or we can start it at 990 and then reverse the results from there too, by just basically running it through a for loop and then subtracting from there also. We then can specify the maximum number of results we want returned with each query. Now you're limited to, you can either return one result and then run another doGoogleSearch query and get another single result from there, or you can get a maximum of 10 results each time. The tool itself is actually automatically configured to actually do maximum results of 10, just basically to not cost the API key unnecessary searches, and therefore tax it. Then we have the filter parameter. This isn't actually the safe search parameter. This is the filter that actually removes near duplicate content. So if we find the same search on 2 different hosts within a domain, Google will actually remove that from the search results. So we can specify that we want those duplicate contents included as part of our search. Okay, to continue on with the doGoogleSearch SOAP SOAP search message. We then have the restricts parameter. Now what this does is we'll restrict our search results to specific things, such as the US government, which is specified by Uncle Sam, Linux, which is specified by Linux, FreeBSD, which is specified by BSD, and the various country codes such as US, FR for France, AU for Australia, that kind of thing. We then can specify the safe search. So if we want to incorporate safe search as part of our search, which we don't obviously do in the download index cache tool, because we want to pull all the content that comes through the site, no matter how offensive it is. And then we have the language restrict. So that will essentially restrict language to restrict the search results to pages that are created in specific languages. So if we didn't want to just search for English, search for French or that kind of thing, we can restrict our page results returns to that. Finally, we have 2 deprecated parameters for input encoding and output encoding. Google did originally support encoding in multiple Unicode formats. They've now deprecated that, and it only supports UTF-8 at the moment. So you can essentially, when you pass your SOAP message, put anything in there. So some people put nothing, some people put UTF-8, and I've seen some scripts still with Latin 1 and that kind of thing specified. So when we get our response from passing the doGoogleSearch SOAP message, what we get, and this is a data dumper of the within Perl of the actual SOAP message as it's returned. We get the search time, so that's the time that Google actually spent to generate the results. We get the end index, which is the last result that we've returned. Now, if you flick that back over to the the SOAP message that we sent, that's actually 9. In the end index, it actually adds them. It actually adds the +1. We then get any search comments which are specifically related to if Google removed any stop words. Document filtering, if document filtering was applied as part of the SOAP message that we sent to Google. And then we get the search tips. So essentially that's tips that Google, if you're going to repeat the search, what they've provided as a recommendation. We then get the estimated total results count. Now for this, it's obviously vastly exceeded the 1,000 search queries that we can run per day and search within. So obviously the tool itself is going to fail. So even if we wanted to go past that 1,000, we can't, just by the restrictions placed on passing the SOAP message to Google. Okay, we then have the results elements, so which are essentially as each of the 10 or each of the number of results that come through, generally the 10. This is how they're all specified. So the related information present means essentially we can use the related search operator to go through the to run against the search result, and we can then get the related searches from there. If the host name is if we provided the filtering option, and if it's locked on, that will actually specify the host name with the duplicate results. Okay, and then within our result element, we get the URL of the actual search itself. In this case, if you actually see it, I was actually doing this is for the TCP input text products, because you can see the 8080 as a TCP port. The snippet is the actual 2 to 3 line snippet we get with the Google search results. We then get how Google has classified it within a directory. So we get its viewable name as well as if it's encoded, if it's any encoding. And then finally we have the summary of the results. So if it's within the directory, what the summary of that actual directory category is. We then have the size of the cache as it's stored within Google. And then finally we have the HTML title as well as the directory title within the actual Google directories itself. And then from there, every other result element is specified, as you can see by the ellipses here, just under the bless statement there. So when we actually run the tool, this is what it looks like. So this is only just the proof of concept at the moment. So we get the standard blurb. We then get what our Google SOAP Search API key is, which in this case I've just hidden the Google SOAP Search API by using a SOAP proxy. We get the search results. So in this case, this is the results from 1 to 10. And we then get the, as it's downloaded each page, what the URL is and that kind of thing. So what I'll show you now is the actual tool itself running. Okay, so this is it running in real time. So you can see it's actually reasonably quick now. Obviously if we had more content than sort of running into like greater than 100K, so if we were downloading a meg at a time, that would be quite significant. Now the other thing that we're downloading too is when we're pulling the cache page through, we'll actually get URL references back to the actual original images. So when you go and inspect the individual content as it's downloaded, because it stores it in directories based on the URL and then cascading down from there based on the URI fields, we get the individual pages from there. So if we wanted to, for instance, see the page itself running, Okay, we can use the verbose option. So essentially as it downloads each one, we can see that it's pulling stuff down through the cache from there. So that essentially gives us the knowledge that the product itself is actually working and actually pulling stuff through. Okay, if I just go back slightly. Oops. Sorry, wrong one. Okay, we can see it still specifies the message that it's outputted by each one, which is just essentially done by 3 spaces, so we can actually still see it running the output as it did before when we didn't run it within the verbose mode itself. Okay, so how does the actual tool run and how does that actually correlate back to the Google Soap Search API? Well, we can see when we run the command, we specify the first argument, which is google.com, and essentially that is the query parameter of the doGoogleSearch Soap message. We then have the API key specified, so that is obviously specified within the doGoogleSearch message as the key variable. And then finally we have the search results. So what we get is where we're going to actually start the search from. So while that's listed as 0, when the soap message is actually passed on, it's added by +1. And therefore our max results, if you look at that inversely, is 9, but it's in fact actually 10 when it's actually submitted as a Soap Search API message. Now, what we finally have is when we get our doGoogleSearchResponse soap message back, we have the URL, which is obviously video.google.com, adwords.google.com, and the iGoogle customized console interface, which is available from Google if you have a Google account. And on the right hand side we have the cache size response. So Google themselves will actually add the kilobyte specification then. So that's in the square brackets on the right hand side there. So the tool itself is is incredibly simple to use. It's not complex. There are actual options there that will actually specify and take you through the 1,000 search results, that kind of thing. But to actually just introduce this tool, I figured I'd keep the demo as simple as possible. So are there any questions or on the tool? Yep.
How do you control if you can't get new Google API key?
An interesting question. I'll talk about this later on. One of the actual planned projects is to use a SOAP HTTP proxy. So essentially what it'll do is you reconfigure api.google.com to point to your local host or to another IP address, and then it will pass the SOAP messages from there. And on the inverse side of that, when it sends the message to Google, it will actually send it as a search query. Now there are SOAP Search API products out there that already do this, such as Aurora from SensePost, but that doesn't actually support the cache page and get cache response mechanism, which I didn't cover because with that API, you only need to specify the URL and the key, and then all you do is get a response from there. So it's not as interesting as the doGoogle search methods. So we are looking at creating a tool, Damon, that essentially does that. When that's going to be released, I don't know. Not within the next 6 months. This product itself is actually expected to be uploaded and published after RoxCon, which is in late November. So I'll have the public release. And the only reason we're holding the release off at the moment is to basically get it reviewed by the OWASP reviewers from there. Any other questions? Yep. Sorry, I can't see you. Yep.
What's your recommended target audience for this tool? Like, do you use this during, say, day job? Do you use this during your profession, or what kind of field would you recommend using this tool?
Probably the penetration testing and audit communities would benefit mostly from this. The tool itself, and the way I'd recommend, especially if you had an organisation that would look at doing this, is to just actually use the Google Alerts. So just run that specific site query, and then as new content is actually indexed by Google, to do it from there. But generally the audit community is what we'd find, so penetration testers, that kind of thing. There is talk of actually doing a reporting tool on the back end of this, but you know, it's fairly simple just based on the way that it's stored in the directory to locate which URL the cache page refers to, if you were to include it automatically in a report. Well, it supports both black and grey box testing, but I mean, with Google it's a simple on-off kind of thing. There's no in-between. There is, I'll cover the other tool shortly, just briefly, but obviously due to time constraints, because I'm seeing I'm racking up sort of 43 minutes at the moment, so. Any other questions? No? Okay. I'll just cover the project sort of briefly. The tools themselves are built under Perl. Perl was just a natural choice because everything else that's in the Google Search API, a majority of that code is in Perl, but it does support Java, .NET and a few others. So to actually rig this tool up, we predominantly use the SOAP Lite module. There's talk within the review community of using the net.google CPAN module. And for code quality and that kind of thing, we use the Perl Critic, which is obviously based on the Perl best practices. And our development environment is predominantly based on Eclipse with the Epic Perl plugin. So that essentially supports syntax highlighting and running Perl and everything automatically within the IDE. And the repository we use at the moment is just based on Subversion, simply because that's proving to be a more popular repository tool at the moment. The code itself is actually stored on, is actually held at code.google.com. The actual URL for that is /p/Google hacking. One thing I will add is you can't actually find it by the Google hacking tag, because Google themselves don't allow you to tag projects such as in that manner. I don't know why, but they just don't. So if anyone's actually interested in actually participating in the project or just reviewing it or sending me criticisms or whatever, in terms of, or would like to see something sort of brought up, then please by all means approach me after this talk, because we're definitely looking for reviewers at the moment. In terms of the actual roadmap, I've got a few presentations coming up. So straight after this conference, I'm flying to San Diego to go to TalkOn, where I'm presenting a 20-minute talk based on the TCP input text proof of concept. And what that essentially does is we'll take Google search results, and for every host or subdomain that it locates, it will actually give you the corresponding TCP port, which you can then input into Nmap and Netcat and that kind of thing. So it's more or less a simple regular expression tool of mining Google search results. And it will actually natively support generating the Nmap and Netcat command lines for you. I'm doing the TalkOn presentation is actually a 20-minute talk. At Sector, I'll be combining both this presentation as well as the TalkOn presentation for an hour presentation in Toronto, Canada, which is in early October. And then finally, hopefully once we can get the the project reviewed and everything, we can do a release at RuxCon, which is late November. So I'm again presenting this talk there, and possibly anything that we've added in the project from there to do it. Okay, so this is the actual timetable. So we're just going to refactor the code as it is now. We're intending to do the public release at RuxCon. At the moment, it's scheduled for to be checked into code.google after RuxCon. The only reason that is because when I return to Australia in late October, I'm actually responsible for the wireless network for RuxCon, so I run the Aruba Wireless there. And then our next intention is to do a half-day training course, which covers both the content that I presented in Australia as well as here, and then any other additional content for the first quarter of 2009. Now at the moment too, I have some other research going on in terms of reverse engineering and all that, so depending on when the other conference CFPs are released, that may get pushed to Q2 or that kind of thing. So in closing, I'd like to thank the people that pushed this project through. Justin Derry, who's essentially the most senior OWASP person within Australia. Mark Curfey, who's the actual OWASP founder, who is actually interested in that SOAP to HTTP scraper. Dennis is actually the OWASP board sponsor, and obviously Paulo is the OWASP project manager. And I'd like to thank also Martin, who is actually here from Europe at the moment, for giving me the On the Move funding, and then obviously Tom, Kate and Alison for their assistance during the project itself. Finally, that's the presentation schedule as it is. All the presentations will actually be released and published on SlideShare, as I mentioned before, so you don't need to go to those. All the video and that kind of content will also be pushed from there. Yeah, sure. Yep.
So I think it'd be cool if you took the results and for each result you sent like an end request to the non-cached version and see if the response is now 403 or 401 or something. Then you can tell this used to be open, but now it's hidden. It'll be kind of like a clue to search through all your results and say, this is something that you might be interested in. That's fantastic.
Well, the other thing is too is Google won't actually retain all the cached content, so you can still get search results but nothing in the cache itself. There's another possibility of using the tool to actually do the urgent page removals. So as Google lists the content, which you can currently do through the webmaster tools. So we are looking at doing that, and if you were actually to go and use like a cached version of the actual page, you'd probably go to Wayback Machine. So that way you get a historical archive from there.